My research is really about applying and using biology in space. I'm actually a biologist by training, and now I'm working in the field of space exploration. And I have two ways in which I explore the role of biology in space. The first one is to develop closed-loop ecosystems that provide humans in space with fresh oxygen, food, fresh water in space. Now, the goal here is that in space, resources are very scarce and it's very expensive to bring resources into space. So when you're in space, you really need to think in a circular way, but in pretty much the most extreme way you can imagine. So space becomes like a sort of a place where you can almost re-envision the future of Earth. It really forces you to start thinking about sustainability from a blank slate and in pretty extreme ways. And of course, that brings a lot of lessons that we can apply back to Earth. And specifically those ecosystems, they are composed of plants and bacteria that basically recycle all human waste, everything that a human produces, and then all these organisms gradually break down those molecules into nutrients that are useful for plants, and then the plants can provide oxygen and food for the astronauts again. The system I'm talking about here, and the system I've been working with for more than 10 years now, is called Melissa. Melissa is a concept from the European Space Agency. They've been working on this for more than 30 years, that is specifically focused on developing a working ecosystem in space. So that's the first way in which I apply biology in space. The second way I'm using biology is by working on bio-inspired engineering. This is really using concepts from biology and embedding them in engineering. And more specifically, I'm working on systems in space, spacecraft that are developing themselves and growing. This might sound a little odd, a little strange and unexpected, because a spaceship is not something you would expect to grow. But the idea is really that in deep space, interstellar space, which is my field of interest, there is a lot of uncertainty. You have no idea what's coming your way, or limited amount of information about what's coming your way. So you need to develop systems that really adapt themselves, that are really capable of dealing with this uncertainty. And I think developing systems that can deal with high levels of uncertainty using principles from biology, of course, is very relevant for the times we live in today here on Earth, because we're engulfed in uncertainty on all kinds of levels. And I'm very specifically talking about two different things. I'm talking about developing a radically circular way of thinking, and I'm also going to talk about bio-inspired engineering. And over the past few years, I've been working with different space agencies, with the European Space Agency, with NASA, and I will present some of my insights that I've been developing over the years.